This is practice quiz 1 for quiz 5 in the second try of Algebra 2. So the first page is just find all of these features. You need to refer to your list of things. So there's the canceling. So vertical asymptotes, after canceling, you set those factors equal to 0. Can there be more than one? The answer is yes to that. Find all horizontal asymptotes. So note that your power, so if we expanded this out, this would be 2x cubed something over x squared something. So the power is higher in the numerator than the denominator, so that means none. Find any point discontinuities, just the x value. So we canceled at the x minus 1, so that factor is going to get set equal to 0. Find any x-intercepts. So this is where you take what's left after you cancel equal to 0. We have 2 of them. Pretty easy work. You can do this mentally to move along quicker on this. Let x equal 0 on this. So, I would recommend, maybe looking at your calculators table, but you're going to get 2 times -1 times 2 times -4 over -1 times 3. So this is going to be -16 over 3, which is -5.3 repeating, you would see on the table. Are there any oblique asymptotes? The answer is yes. You don't have to figure them out. But notice after canceling that the power would be 1 higher, so it'd be 2x squared something over x to the first. You have that power that's 1 higher in the numerator after canceling, but we're not going to figure it out. True or false, the domain is all real numbers except 1 and -3. So we need to take out this, and that's exactly what we did, what the statement did. Okay, so brings us to problem 8, and we want to start off by factoring this. So factoring, you need to get that right. That's something that I won't explain because I've done so much explaining of it. And then cancel those x plus 3s out. Those will drop. Okay, so find all vertical asymptotes. So you take the denominator, set it equal to 0, you get -2. Mental work now. Find a horizontal asymptote if it exists. So notice that the highest powered terms right here, they're the same. So now we go back to the ratio of their coefficients. Find any point discontinuities. They're going to exist. So it's going to be -3. Set the cancel factor equal to 0, and then take that into what's left. And you should write this out. So this is -8 over -1, which is 8. So -3, 8. And you should check that out on your calculator just to make sure. So what would you see? -3 error. And you'd see -2 error. And remember, horizontal asymptotes we cannot see. Okay, so there are no obliques. We can go right there. So these are linked. So if you say yes, there is a horizontal asymptote, then definitely there's not an oblique. Find the y-intercept if it exists. So x equals 0 in. So -5 over 2. That's what y equals, so -2.5. X-intercept, take what's left after canceling equal to 0. You should be able to mentally do that again without writing that down. So there's everything you need. We are ready to draw the graph. So -2 is our vertical asymptote. And then 1 is our horizontal asymptote. Okay, -2.5 is the y-intercept. X-intercept is 5. And the point discontinuity, -3, 8. 3, 4, 5, 6, 7, 8. So it's like way up here, way up here. And so the graph will be something like that. And then the lower piece of this will be like that. Okay, so the domain, we need to take out -2, and we need to take out -3. And then the range, y is an element of the reals, we need to take out 1 and 8. So remember again that this point discontinuity will appear on the end like that if you have it. Problem 9. Okay, so we have some factoring to do. And this will be x plus 3 over x plus 3 times x plus 1. So we have some canceling that will happen and leaving a 1 on the top. This means there will not be any x-intercepts. If there's not an x on the top, you have no x-intercepts. So find all vertical asymptotes. Again, you should be doing this mentally. Find all horizontal asymptotes. So notice now that the power is greater in the denominator. So this is going to be y equals 0, the x-axis. Automatic, you just say that. And so if that's the case, there's no oblique. You can go right there immediately. Point discontinuities will occur at -3. So set that equal to 0. You should be able to mentally do that. And then 1 over -3 plus 1, -1/2. So -3, -1/2. Find the y-intercept, let x equal 0. Okay, so y equals 1. And then we're good. So sometimes once you get this, this is very quick and not difficult. The only difficult thing would be when we actually do have an oblique asymptote. And I don't think I'm going to give you one of those other than in the practice. So -1 and 0. Okay, we're good. And then -3, 1/2. So this is what this will look like. How do I know? I don't have it memorized. That's for sure. Oops, I messed that up completely. That's the hole. So that means this branch is down here. Because how do I know is because it's got to go through all the features and it's got to hug the asymptote. So this is out. And then the other branch will have to go through the y-intercept right here. And there's not an x-intercept, so it will look like this. So get rid of this branch. So that's how I know. You have to go through all the features and it has to hug the graph. It has to hug the asymptotes, I meant to say. All of those things have to happen. So the only way for that to happen is for those branches to look like that. So domain, we're going to take out -1 and -3. And then the range, we're going to take out 0. Make sure you take out, so, and -1/2. You know, if it's 0, if it's the x-axis, you still have to do it. Okay, make sure that you see that those are the same. All right, so the next page is new, but it's real easy. So write a rational function to model this situation. So each student costs $5 for food, and the dance costs 800. So this is the total cost, 5x plus 800. and X is the number of students. Because again, $5 for food for each student. And we're going to divide that amongst X students. So there you go. That's the function. That's what it's going to look like. Find the horizontal asymptote. This is going to be 5. So again, you're looking at anytime that you have a rational function, the highest powered x's, and you divide them. If the power is the same, you take the rational, you take the ratio of the coefficients. If the power is higher in the numerator, which it won't be in this case, there is none. And if the power is higher in the denominator, it's 0, the x-axis. And then if the power is higher by 1 in the numerator, and you still have a algebraic denominator, then you have those goofy oblique asymptotes. Okay, what important quantity does this represent? So this is the minimum possible price of each ticket. It actually never gets there. So what a horizontal asymptote is like when X is getting extremely large. So as more and more students decide to attend the dance, you'll get closer and closer to $5, but you actually will never get there. So 450 students sign up. So now you just put 450 in. So this is just like evaluating off your table over 450. And that's 678. And that's the end of the quiz. And for those of you that want to struggle through special right triangles, here we go. Okay, so this is 30, 60, 90. This one right here, let me try to zoom in a little bit. So remember, the ratio is always 2 to 1 between the angle or the side that's across the 30 and the hypotenuse. And then the other side is times the square root of 3. So let's just go and figure all these out. Here's the other one, 30, 60, 90. So this is the side across from 60. So this must be 8 and 16. You should be able to go that fast with the values I give you. Oh boy. What about 45, 45, 90? So the hypotenuse is times the square root of 2 from the given equal legs. And if you have the hypotenuse and you have the square root of 2, then the legs are just this value in front. Now, they're not always that easy, but for the sake of the spiral, I make them that easy. And if you just want to put your values around the triangle and not write them down, that's fine. That will tell me you have this down. And then y is 16. And z is 8. Okay, so that's practice quiz 1 for quiz 5 in the second try for algebra 2.